Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, distribute elements into two arrays 2. The problem is interesting and in particular if you have followed the segmentary series in this channel or at least followed a couple of videos in that series, you should be able to approach this problem by yourself. So if you haven't tried it yet, pause the video and give this problem a try by yourself. So let's get started. The problem states that you are given one indexed array of integer nums and you have a function greater count which, as the name suggests, will return how many elements in the first input param array is greater than the second parameter, which is value. Now you need to distribute all the elements in the given array nums in two arrays, array 1 and array 2, in n operations. Now in first operation you will append nums1 to array 1. In second operation you will append nums2 to array 2. Now afterwards, for any operation, for any ith operation, you will figure out how many elements are there which are greater than nums of I in array 1 and how many elements are there which are greater than nums of I in array 2. Based on which array has greater number of such element, you will append the number to that particular array. Now if both array 1 and array 2 has equal number of elements which are greater than nums of I, you will append nums of I to the array with lesser number of elements. Now if both of the array has equal number of elements, then you will simply append nums of I to array 1. Now the result is basically the concatenation of array 1 and array 2. So if array 1 is 1 2 3, array 2 is 4 5 6, the result would be 1 2 3 4 5 6. So you have to return the array result. So let's take an example. Let's say nums is 2 1 3 3. So we have to divide this into two arrays, array 1 and array 2, and then finally we will concatenate those array and return this particular result. So the first operation is fixed. You will append nums of 1 to array 1. Similarly, second operation is fixed. You will append nums of 2 to array 2. So after two operation, array 1 will have 2, array 2 will have 1. Now in third operation, you have to find which of the array should 3 go to. So you will figure out first how many elements are there which are greater than 3 in this array, how many elements are there which are greater than 3 in this array. Both of them has 0 elements, so they have equal number of greater elements. So you will see which of them has lesser elements overall. So this has just one element, this has just one element, so they both have equal number of elements as well. So you will simply append nums of I to array 1. So after third operation, array 1 will contain 2 and 3, array 2 will contain only 1, right? Now comes fourth operation. So you have to figure out which array this fourth element will go to. So again you will figure out how many elements are there which are greater than 3 in array 1 and in array 2. So both of them has 0 elements because 3 is the largest element, so there can't be any element which are greater than 3. So both of them has equal number of elements, so you will append the nums of I to the array which has lesser number of overall elements. So array 1, if you remember, contains 2 and 3, array 2 contains just 1. So array 2 has lesser number of elements, so you will simply append 3 to the array 2. So array 1 at the end will contain 2 3, array 2 will contain 1 3. So final result would be concatenation of these two arrays, which is 2 3 1 3, right? So hope the problem statement is clear. Now how to solve this? So what is the brute force approach? You will simply simulate whatever is given in the problem statement. So basically you will, in first operation you will say, okay, I know that in array 1 we will first append this element 2, right? Similarly in array 2 we will append the second element, which is 1. Now for every other element, that is starting from operation 3, you will decide which of these two will this element go to, and how you will decide based on these criteria, right? So after you decide which element to go to, you will try out next operation, and so on and so forth, right? So what is the overall time complexity of this approach? Basically you are simulating whatever is given in the problem statement. So what is the time complexity of this approach? So you will, for every operation, what you need to find out, you need to first figure out what is the value of greater count of array 1 comma nums of I and greater count of array 2 comma nums of I, because based on that only you will decide which of these array you should push element in. So what you need to figure out is how many elements are there which are greater than 3 in this array. Similarly, how many elements are there which are greater than 3 in this array. So for that, brute force approach could be just iterate over all the elements and see how many elements are there which are greater than a particular value. Similarly, iterate over all the elements, figure out how many elements are there which are greater than a particular value. So in total, this will take order and time to figure out how many elements are there which are greater than a particular element, right? So for every operation you are taking order and time to decide the number of greater elements, and after you decide these two values, you can simply follow this criteria to figure out which array you should append the element into. So for each operation you are doing order and operation, so there are total n operations afterwards. So overall you will be doing order n square operations to distribute this array into array 1 and array 2. So this will not pass because the value of n is 10 power 5, so which is very used to pass the given time constraint. So you need to do something better. Now how to optimize this? So notice there was 2n here, right? So first n was coming from the fact that you are finding out the number of elements which are greater than a particular element in both the arrays. That is taking you order and time. And second n is basically you are applying n operation. So this n you can't remove for sure. You have to apply on n operations at the end. So you have to somehow figure out how to answer how many elements are there which are greater than a particular element in less than order and time, preferably log n or root n, right? So how to do this is the question. So the new question is how many elements are there which are greater than a particular element in less than order 1 time. So for finding out how many elements are there which are lesser than one particular element, you can do binary search on the condition that the given array is sorted, right? So you have array 1, let's say as 2, 5, 9 and 10, just a hypothetical example, 2, 5, 9 and 10, and similarly array 2 as 3, 6, 8, 7 or 3, 6, 8, 9, right? So these two are sorted. Now if you keep these two elements sorted or these two arrays sorted, for figuring out how many elements which are greater than 3, you can simply do binary search and figure out how many elements are there which are greater than 3. Similarly here you can simply do binary search and figure out how many elements are there which are greater than 3. So now to figure out the value of greater count of nums1 of array 1 nums1 array 2 nums I is just order log n operation, right? So in just log n time you are now able to figure out how many elements are there which are greater than a particular element. Now after this you can, let's say you decide, okay, I need to push the array, push the element in this array. So for this you are now inserting 3 into this array. So for that you need to figure out the position of 3, that you can figure out using binary search, and you need to make sure that the given array is still sorted. So you need to insert 3 in its sorted position itself. So this operation is something that you can't do easily, like you can't insert an element in a sorted manner in log n time. If you do this, then notice that previously when you are doing a binary search and figuring out how many elements are there which are greater than a particular element, that you might not be able to do in log n time. So in essence what you want is you want to support these 3 operations. You need to insert an element in a sorted manner, you need to find out upper bound and lower bound, and you also need to figure out how many elements are there which are lesser than how many elements are there which are before or after a particular element E. So let's say after doing binary search you landed here, you need to figure out how many elements are there which are after this element. So if you use a set in binary in C++, you can do these two operations very easily, but this operation you can't do in set easily, right? Because figuring out how many elements are there after a particular element is something that will take you n log n time in set, right? So this exact problem we have discussed multiple times during the segment tree series. In particular, this is the first video where we have introduced that particular concept. If you can see, this are the exact three things that we wanted to figure out. So I will not explain the entire things. Instead, I would recommend you to watch this video after maybe 16 minutes. So you can just watch this 15 minutes of video after 16th minute, and you will be able to understand how you can apply segment tree to solve for this particular constraint. And there are other videos as well which are on the similar problem, so you can try other practice problems which are almost on the similar constraint. So I will not explain the exact approach, you can refer to that video, but let's just do one dry run over the entire approach to actually figure out what was the crux. So let's say the crux was basically you will sort the array, right? So you will sort the array, and if you sort the array, these two operations will be gone, right? Because now if you want to figure out, okay, I need to insert 3, so you know this 3 belongs to this particular index. You don't need to figure out, okay, I need to insert an element in a sorted manner. I will just go to that particular position and I will insert it, right? So this operation is almost gone. Similarly, upper and lower bound is gone, because if you want to figure out how many elements are there which are greater than 3, let's say, you will simply go to this particular index, because you know the last 3 ends here. So after that you will simply count how many elements are there which are present, and all those elements should be greater than 3 automatically. So with simply sorting the array, these two operations are now trivial. The last one is something you can do with segment tree. So basically, whenever you are at a particular index, let's say you are traversing from left to right, so you have initially none of the elements are present, everything is 0, it means none of the elements are present. So whichever element is present, you will just simply mark it 1. So let's say you are at this particular index. So at this particular index, you have visited these two elements. So you will simply mark 2 and 1. So position of 2 is this, right? And position of 1 is this. So you will simply mark these two elements. Now you are at this particular element. So for this, you know, everything afterward is greater. So you need to simply figure out how many elements are there which are marked, or count of elements which are marked. So that is basically the range sum in this particular range, that you can do in log n time using segment tree, right? So in this particular case, when you say give me the range sum in this range, you will get 0. That is, there are 0 elements which are greater than 3 in the array which contain 2 and 1, right? So this is the crux of the approach. Let's do one complete dry run to understand this a bit better. And again, this is not the entire approach. I have explained step by step how to actually get at segment tree solution in that video, so make sure to watch that as well. So now let's do complete dry run. Let's say we want to fill array 1 and array 2 for this particular array, for this particular nums, right? So first element will always go to the array 1. So you will insert index 0 to array 1. So you will simply mark 1 here, right? Similarly, second element will always go to array 2. So you will simply mark index 1 in array 2. Now comes index 3 or operation 3. You have to figure out how many elements are there which are greater than 3. So for that, you also need to have the sorted version with you. So let's just have the sorted version with us as well. Let's simply sort this array and keep it with us. So if you sort this array, the array would be 1 1 2 2 and then 3 3 3 and then 5 and 9, right? So this is the sorted version of the array. Now you need to figure out how many elements are there which are greater than 3. So for that, you need to now query this particular range, right? Because you will look at the sorted version, you will see this is the last 3. So afterwards I need to query. So I will query for the sum of element in this range, sum of elements in this range, and that will give me the value of greater count for array 1 nums I, array 2 nums I. So in this particular case, both of them will give me 0, and because they both are equal, you will simply insert the element into the one which has lesser element. Both of them has equal element, so you will insert into the one, insert into the array 1 itself. So you will insert index 2 to array 1. So index 2 lies here, so you will simply mark this particular index, right? Now you are at operation 4. So again the same thing, you will simply figure out the range sum here, figure out the range sum here. Both of them are 0. So you will simply say which of them, whichever has lesser element, you will insert that, insert this index into that. So both of second array has lesser element, so you will insert index 3 in array 2. So index 3 lies here, so you will simply mark this particular index. Now let's do one last thing, or rather let's continue for few iterations, because we are at index 2, so we need to figure out how many elements are there which are greater than 2. So these are all the elements which are greater than 2, because you can see all of them are greater than 2, right? So for this you will simply figure out the range sum in the range 5 to 9, and similarly you will figure out the range sum in the range 5 to 9. So both of them will give you 1. So that is, there is just one element which are greater than 2 in array 1 and array 2 as well. So if you look at it, array 1 is containing 2 3, array 2 is containing 1 3. So indeed there is just one element which is greater than 2 in both the array. So this one is that. Now because both of them has equal number of elements, you will simply insert into the one which has lowest element. Both of them has equal number of elements as well, so you will insert into array 1 itself. So you will insert index 4 into array 1, right? So in the same fashion you will continue doing this, and after you have done you have gone through all the n operations, you will have your nums1 and nums2 populated. You can, or array 1 and array 2 populated, and you can simply append them, and that will be your result, right? So what will be the overall time complexity? So notice what you are doing. For each operation, you first figure out the number of elements which are greater than this. So for that, you are first doing you are first figuring out after which index I should consider. So for that, I can simply do upper bound lower bound on this array and figure out what is the index that I want to consider, right? So let's say for 2 you are trying to figure out, you will do upper bound for 2, you will get this particular index, so you have to do a range sum in this particular range. So that will take you log n time, right? First figuring out how many or which index, starting which index you will apply the operation. Now after that, you need to count the number of active elements here, and similarly you have to count the number of active elements here. So both of them will take log n time. So again 2 extra log n's here, 1 for each. And after this, you now know which of these array you need to insert to, right? Based on the operations. So let's say you decide to insert into array 1. So for that, you will go and mark that particular index. So that will take you extra login time. So this is simply login because you will either mark here or mark here. You will never mark in both, right? So overall, you are taking order login operation for each operation, and in total there are n-2 or order n operations. So in total, the complexity of this approach will be n log n, right? So if you have watched to this point, I would strongly encourage you to pause and try to code this entire thing by yourself. Again, you don't know segment tree should not be an excuse to code this solution. You can simply copy paste the segment tree part from any other code. You can use mine as well. I have created a class, so you can simply use the class in your code as a black box and code the rest of the function by yourself. So in segment tree here, what you just need to figure out, you just need a way to figure out the count, the sum of elements in a range, right? So for that, you can simply use simply copy paste the segment tree part and code the rest of the logic by yourself, right? So next we're looking at the code. Again, I assume you have at least tried by at least once, because unless you try this kind of things by yourself, no matter how confident you feel after watching this video, more often than not you will not be able to apply this concept in the future problems. So it's most important to try it out by yourself. So this is a segment tree class which contains query and update. Update will go to this index and add this particular value, and query is between this and this, what is the sum, right? Now we'll not go to the segment tree specifics. So after, we want to divide this nums into two parts, array1 and array2. So first of all, we have created two segment trees of size n+1, and we then sorted all the elements of the array while keeping the indexes with us. Now after this, we will prepare this particular array, that is zeroth index will go to index 2 of the sorted array. Similarly, first index will go to index 0 of the sorted array, right, and so on and so forth. So this we will prepare by simply iterating over the sorted array and mapping the indexes, right? Now once you have prepared this in just order one time, you can now say okay, I am at 5, so where does this element will belong in the sorted array? That you can just simply look up in this array and you will say okay, 8 is the sorted index for this particular element. Now after that, we simply insert nums of 1 or nums of 0 to array 1 and nums of 1 to array 2. Now insertion, basically we are keeping an array with us as well, and this segment tree is already there with us. So this segment tree is nothing but this particular array in a tree format, right? Now notice in the tree we updated the sorted index position, right, because we want to update the position which is in sorted array. So similarly, for in the tree 2, we updated the sorted index position for index 1. Now after we have done this for all other indexes, we have to figure out how many elements are there which are greater than nums of j in array 1, how many elements are there which are greater than nums of j in array 2. For that, we need to first figure out what is the starting index after which all the elements are greater than nums of j, right? So basically you have to do upper bound or lower bound with nums of j. So we simply do upper bound with nums of j, and we put n here because we want everything after nums of j, right? So this is just a way to figure out how many elements the first index which is greater than nums of j. Now after you figure out the first index greater than nums of j, you will query in the range this to this, right? Now because this index can be after the array, that is this index can be n as well, so that's the reason I created a segment tree with n+1, so that even if it is n, I will assume that there is nothing at n is infinity. So that's just one small thing. If you can also use if n is less than r, return 0 kind of. So this is just one simple trick to not have if else everywhere in the code. And finally, we also like noted the sorted index value. Now this will use while updating the trees, right? So the first condition is if left gt is greater than right gt, that is number of elements in array 1 is greater than number of elements greater than nums of j in array 1 is greater than number of elements greater than nums of j in array 2. In that case, you will append nums of j in nums1 or array 1 and also update the tree as well. And in the tree, you will update this sorted index. If it is lesser, if then you will update the array 2. If both are equal, you will see which of them has lesser size. If nums of 2 has lesser size, you will update nums of 2. If nums of 1 has lesser size, or if both of them has equal size, in both the cases you have to update nums of 1. So you will update nums of 1 here. Now after doing this entire exercise, you will have nums of 1 and nums of 2 populated. So you will simply append both of them and return your final result. So hope this entire solution makes sense. If you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.